Good morning, students. In this video, we are going to see about the types of ROM which is there in the memory system. So the types of ROM. So in generally, the ROM is going to be classified into 5 types as mask ROM, PROM, EEPROM, EEPROM and flash type ROMs. Let's see about the first one, mask programming or mask ROM. A mask programming is done by semiconductor company during the last fabrication process of the unit. This procedure is costly because the vendor charges the customer a special fee for custom making the particular read-only memory. For this reason, mask programming is economically only if a large quantity of the same ROM configuration is going to be ordered. For a small quantity, it is more economical to use a second type of ROM called as programmable read-only memory. The hardware procedures are the things we will see over here. So as I said, the connections made by the semiconductor vendor for the mask ROM, and which is going to be an expensive setup and several weeks for delivery. It's going to be taking a delay over there, and whenever we are going to have an high volume, then only we can go for that. The mask ROMs are manufactured with a bipolar or MOS technology. And the next one, read-only memory, the programmable read-only memory. A programmable read-only memory, the hardware procedure for programming read-only memory is irreversible, and once programmed, the fixed pattern is going to be permanent and cannot be altered. Once a bit pattern has been established, the unit must be discarded if the bit pattern is going to be get changed. So here, the programmable read-only memory, the programming is going to be done by a process called as vaporize fusible links. That's going to be called blow links with a programmable read-only memory, which have been done by the programmer by using a high voltage or current, allowing the current pulses allowing to the particular memory. And it's available in the process of bipolar technology, and it's a one-time programmable. Coming to the third one, erasable programmable read-only memory, it can be restricted to the initial value even though its fuses have been blown previously. Certain PROMs can be erased with electrical signals instead of ultraviolet. Then we can call it as an electrically erasable programmable memory. And flash memories is a form of electrically erasable programmable read-only memory, in which a block of bytes can be erased in a very short duration. So as I said, the erasable programmable read-only memory, a charge trapped on extra floating gate of the MOS transistor, and which is going to be get programmed with help of an UV rays, and the electrically erasable programmable read-only memory, which is going to be get used with the electrical current pulses. Let's see in detail about the programmable read-only memory, PROM, which allows the data to be loaded by the user, and which is going to be get achieved by inserting a fuse at a point P. In the diagram already we have come across over there in the cell, there the point P, which is going to be a fuse. By inserting a fuse or diffusing a fuse, the content may be get programmed over there. Before it is programmed, the memory cell all contains zeros only. The user has to insert one at a required locations by applying a high current pulses. Once it is going to be get processed, the data is going to be irreversible. So it's going to be used only once the user can program, and they can be get used over there. The erasable programmable read-only memory also allows the data to store and to be erased, and a new data can be loaded over there. The erasable program is going to be done by allowing an ultraviolet rays to the chip. A small window will be there upon the cell, and the structure is similar to that of a ROM, and we are going to allow the UV rays upon that. By allowing the UV rays, which dissipates the charge trapped in the transistor memory cells, and it's going to erase all the data, and again it can be get programmed as per the user need. Coming to the electrically erasable programmable read-only memory, which has an problem, the disadvantage which is going to be there in the erasable programmable read-only memory is nothing but all the content has to be get removed by applying the UV rays. Hence, we have to remove all the data which have been present over there. To overcome that process, we are going for the electrically erasable programmable read-only memory. Here what happens, here the needed data only can be get erased by selecting the row and column, and we can allow the particular current pulses to the particular selected bit and the word line, so that the content can be erased and the data can be rewritten over there. It's a block of data has to be get erased and it's going to be get rewritten. If you're going to see about the disadvantage of this particular electrically erasable programmable read-only memory, a different voltage is need for erasing here as well as for writing and for reading. So a common voltage is not necessary or not able to be used to read the content or to write the content or to erase the content. For all the three different operations, three different voltage ratings has to be get used over there. That is a major disadvantage of this electrically erasable programmable read-only memory. This is a structure which have been shown over here in this. So if you're going to see about that, your floating gate is going to be present over there. So through this floating gate, we are going to do the process of erasing and writing the data into that. So here all the word lines are going to be active and the bit lines are going to be active low, and here word lines are active high and the bit lines are going to be active low. During that time, the floating gate can be get fused or diffused, or it can be get connected. Hence such a way we are going to make the writing operation into this particular cell. Coming to the last type, a flash memory. A flash memory, if you're going to see about that, as I said that it can a block of bytes can be erased in a very short time over here, and storing message in a mobile phone or storing a photograph in a digital camera are the examples of this flash memories over here. Here an approach, what happens, a flash cell is going to be based on a single transistor controlled by the trapped charge. Hence what happens, the flash memory can read the content of a single cell, but we can write only a block of cell. Okay, so here it can be a higher density as well as the low cost it's going to be present over there, so which requires a single power supply to do this process. So there's no need of any different power supplies for this one. Such a way we're going to do that one. So in the flash device, it is possible to read content of a single cell and write the entire block of data, as I said to you. So prior to writing, the previous content of the black block has to be erased over the example. In the MP3 player, the flash memory stores the data that represents the sound. A single flash chip cannot provide the sufficient storage capacity for the embedded system. That's a problem over there. So coming to the advantages of this particular flash memory, flash drives have greater density, which leads to a higher capacity and a lower cost price, which requires a single power supply and consumes very less power. There are two methods of implementing the large memories. One is going to be called as flash cards and another one is going to be called as flash drives. Flash cards, one way of constructing a large module is to mount a flash chips on a small card. Such flash cards have standard interface. The card is simply plugged into a conveniently accessible slots. A memory size of the card can be an 8 MB, 32 MB or 64 MB, like that it can vary, etc. Example, if you're going to see about that, a minute of a music can be stored in 1 MB of a memory. Hence a 64 MB flash cards can store an hour of music. Coming to the flash drives, flash drives have a larger flash memory can be developed by replacing the hard disk drive. The flash drives are designed to fully emulate the hard disk. The flash drives are solid-state electronic devices that have no movable parts. So hence what happened, which can be designed to a fully emulated hard disk. Even though it's not yet possible, but even we can do that, and which it has an shorter seek and access time. Hence a faster response is going to be present over there. So let us see about the advantage and disadvantage of these flash cards and flash drives. So flash cards and flash drives have a shorter seek and access time, which results in a faster response, and they have low power consumption, and they are attractive for battery driven application, and they are insensitive to vibrations. The disadvantage, if you're going to see that the capacity of the flash drive is lesser than that of the hard disk, and it is, if we want to improve the storage capacity, obviously it leads to a higher cost per bit. Flash memory will weaken after it has been written a number of times. Typically, at least 1 million times can be get reused.